and it looks like we've got audio. That's excellent. So thank you to everyone for tuning in today. For those who don't recognise my dulcet tones, my name is James. I'm one of the organisers of the Melbourne Azure Security Meetup. And we're here tonight to hear from David O'Brien. Now, David's one of the Melbourne MVPs, contributors to the Melbourne Azure community, has a strong background in consulting and runs his own consulting group. But most recently, David's been spending a fair bit of time building a startup and a CSPM product from the ground up using cloud native tooling. So we're going to hear from him about that process. Before we get too far into everything, we're going to have our next event on the 16th of March at 7 p.m. online, and that's from a local presenter, Tim O'Neill. He's a Kiwi, and he's going to be talking on the learnings that everyone has available to them from SolarWinds, from the SolarWinds breach that obviously has been across the news recently. As always, if you would like to present or get involved, please do feel free to reach out, and you can do that either on LinkedIn or using the Meetup page. So without further ado, I'll hand over to David and we can get going.
Good. Thanks, James. All right. Good evening, everybody, or good whatever time it is that you're currently watching this on YouTube. So today we're going to talk about how we are building a CSPM on Azure. Quick one about myself. Yeah, okay, good. There wasn't too much audio feedback. Okay, quick one about myself. My name is David O'Brien. I am a Microsoft Azure MVP, as James mentioned. Cloud architect for the last 12 years or so, 12, 13 years. And I started a company called Argos Cloud Security last August, actually. The product has been in development for a bit longer, but officially since August. If you want to get in touch with me, Twitter is usually the best way to do it. Unfortunately, I'm very active there. My blog and the website for our product or our company can also be found here. And if I don't talk about tech, I usually talk about my little family that you can see there, or my most favorite hobby, flying over Melbourne. Good. So just to start off, what is a cloud security posture management product, or what is cloud security posture management in general? You've most likely already come across it in one way or another. On premises, I would probably compare that to something like group policy to enforce certain compliance rules or security standards on-prem. In the cloud, it's really about monitoring your security posture and identifying misconfiguration, because misconfiguration, as I'm going to mention in a minute, is pretty much the issue that we face in the cloud that leads to security incidents. Pretty much every single data breach that you read about, some person, something, some maybe even automation framework did something it shouldn't have done, either intentionally or unintentionally, and that led to an issue. So CSPM is also there to prevent breaches by finding issues early. And like I mentioned, many organizations already have internal guidelines, maybe even your go-live checklists, if you will, that people have to follow or adhere to before they go into production or even into the cloud. So that definition out of the way, and I'm going to explain a few aspects a bit later on, but that out of the way, really the way or why I started was because one day while working on a cloud consulting gig, about 2 years ago, a security incident happened. And I talked to a couple of people in my network about the security incident and how I thought that there has to be a better way to make sure that an incident like this doesn't happen again. And after having a couple of conversations, I decided to really, just before the pandemic started, to start developing that product, and in the middle of the pandemic to actually start this product company. So the fundamental premise of our product idea was that even after years and years, public cloud has been around for over a decade now, almost a decade and a half really, that we still seem to be getting the cloud security basics wrong. Yeah, and this isn't me saying that we don't know what we're doing or people are stupid. It's just cloud isn't easy. Yeah, following those deploy X, Y, or Z in 3 easy steps tutorials that we read or see on even vendor, and that this is not bashing Microsoft, this applies to many, many vendors. These tutorials, they usually end in tears. Whether it's cost or security related, they don't really work well in production or in the real world. Cloud platforms change as we're working on them, and what might have been okay to do yesterday could really potentially be seen as a security risk today. Because we hear about databases being put onto the internet, firewalls left open, websites exploited, and many other things almost on a daily basis. Right? That very typical public S3 bucket on AWS that we hear about all the time is that almost that default that people fall back to when they hear about an issue. Oh, there must have been a public bucket somewhere, or somebody must have left a firewall port open. Things that were okay on-prem are really, really not okay in the cloud. So for me, I thought this is an opportunity to start developing the idea, test the idea out with some people, and get rich quickly, right? James and I, we talked about Silicon Valley, the TV show. That's what I learned from there. You just need to have an idea, pitch it to a couple of investors, and they throw a couple of $1 million at you. And leaving that very last episode aside, without spoiling anybody, you're going to have a fun time. Unfortunately, reality is not a TV show. We're self-funded, so we really need to make sure that we don't go broke while trying to build this application. We truly believe in what we're doing, obviously, but we often face the issue that organizations rather buy from the big vendors, right, than buying an early product version from a startup, which just means that money is even scarcer. And as a startup, you're also rarely judged differently, especially by larger organizations, the big four, the banks, the big insurances. There's a lot of expectations we need to, and frankly, we also want to meet. And in the early days, customers might let us sometimes get away with a few things, but overall, even for free tier products, people still usually expect premium outcomes. So of course, we promise these premium outcomes to our early adopters and customers. We want them to be delighted when using our product. But how do we make all of this a reality? How do we make all of this not a technical problem for us, but make it easy for the developers and make sure really the only stress we feel or our company feels is the experience from being overrun by customers. So we had to put our heads together and understand a few things and make some important decisions. Who's working on the team and what skills does the team, especially our developers, have? Initially, that was me. Because there's no point in selecting a certain programming language if nobody on the current team knows how to write it. Yeah, just because it's cool to write everything in Rust doesn't mean you have to write everything in Rust. We need to make an educated guess about our likely traction for the next 6 to 12 months. We didn't want to build an app that can scale to thousands of users on day one if realistically we were really just trying to get feedback on a really early MVP version. Similarly, we also didn't want to build something that we would have to refactor or rebuild even the second the first customer actually started using the app. Also, we live in the real world, as I mentioned, so we had to understand how much money we actually had available to us to spend on development and also running the actual infrastructure. And lastly, we defined a few non-negotiables for us that had to be true for the foreseeable future. So this is what we came up with. Our golden rules, ideally never to be broken. Never say never, but at least for a while. So based on our available skills and relationships, we decided to go all in on Azure. All in really means that. It means we didn't think about scenarios like what if we needed to move to a different cloud provider in a year or later, because we believe that for a startup, and I strongly believe that this isn't exclusive to startups, it applies to other larger organizations and more mature organizations as well. That this kind of thinking really distracts from delivering value. Yeah, we'd be busier writing code that works everywhere, sort of, instead of writing code that works really well in one cloud and delivers value to our customers. And this is why we also decided to use as many, and I put them in quotes now, serverless services as possible. Because our business is really not to sell virtual machines, figure out how to patch them, deploy Active Directories, and join stuff to them. We make money by delivering value to our customers. And frankly, they don't care about infrastructure just as much as probably nobody in their right minds cares about what infrastructure any of these applications on your phone runs on. Yeah. So this previous manager of mine said, people want banking, they don't want banks. Yeah, they want the outcome. So going serverless to us meant we were able to focus on writing great code, delivering and testing new features quickly in order to get customer feedback quickly. We also needed a very strict focus on security because we are a security product. And in our opinion, that means if we don't follow certain security practices, we fail. We mustn't take any shortcuts when it comes to security. As a consultant, I've seen too many vendors not fully understand that. And I'm not going to go into too much vendor bashing tonight, but it's just something we want to be better at. And Azure also offers many services that have free tiers or certain plans that come with a free usage, basically, to a certain point. And this was, and to this day, still is very helpful to us. Of course, we also needed to integrate with third-party solutions. And usually if there was more than one third-party solution that was good enough to do the job, then the one with a startup tier was selected. There's actually quite a few out there that are very startup friendly. And that goes kind of hand in hand with the buy over build attitude or mentality that I wished many more organizations would follow. So if there's a solution that does what we need to do, then we will buy the third-party solution or use their free tier. Examples of which are sending emails, authentication, or payment services. All of which important, all of which have great SaaS solutions out on the internet, which we were able to use rather than building it ourselves. And last but not least, everything had to be automated. CI/CD really all the way. There was no way that anybody would just quickly go and click this thing in the console because it's so easy, and why would I wait 5 minutes to make the code change? So this is what we came up with. This is our initial architecture diagram that we drew. Very fancy, I know. I'm pretty sure there's many architects out there that are super jealous about these skills here. Skills with a Z, by the way. It's I'm going to go into much more detail next, but really at a very high level, you can see our core application here in the middle. It's actually a .NET Core Azure function app, and it runs on Linux. And because why not? And that really does all the heavy lifting. How heavy? I'm going to mention that later on. Our front end at the top, at 12 o'clock, is a Angular app hosted on Azure storage account, static website basically, behind an Azure CDN. And the backend at 6 o'clock, down below, is an Azure Cosmos DB database. So as you can see, there's no servers, no domains, no patching, none of that old legacy stuff. So you can also see a couple of services here that already we've integrated with at that point, we knew we were going to integrate with. Like Auth0 at like 1 o'clock, top right, for authentication, and SSO for our customers, so single sign-on. Auth0, by the way, also means you bring your own identity to us, which means if you've already got MFA on your identity, which you should, non-negotiable for anybody really, then MFA just works with our application out of the box, nothing we have to do. Then at 3 o'clock, there's Stripe on the right side, which we use for payments, which is great because that means we don't have to worry about storing credit cards and being PCI compliant, because nobody really wants to be PCI compliant. If anybody's ever gone through a PCI audit, I hope you agree. And then at 7 o'clock, there's SendGrid, just another example. And I could ask if we were now in a real room with people out there, if anybody really enjoys installing Exchange servers, because I don't. I've done it years ago, and I'm really, really happy that there's SendGrid now out there, because we can now just, in a few lines of code, send emails, and we don't have to worry about patching Exchange. All right, so let's dive a bit deeper into the actual infrastructure and which services we picked to actually build this CSPM product. So the front end, as I mentioned, that's hosted on Azure storage account with the static website feature. Mainly because the Angular website, the Angular app that we're building is a perfect candidate for this feature. We build the app in our pipeline copies it over to storage account, done. That's all we have to do. Literally takes a few minutes, and that's all we have to do to get this front end up and running. We do have Azure CDN in front of it, mainly to accelerate global delivery of static content. But overall, we do not need to deploy any virtual machines. We don't need to worry about configuring, installing, patching IIS or any other web servers for that matter. We don't have to worry about high availability. Even if we wanted to go into a different region, it's all managed by Azure. And all of this for really the amazing price of $24 a month. I usually mention in other talks that's 24 Australian dollars, not US dollars, which makes people, especially over in Europe, yeah, they make very happy because 24 Australian dollars is pretty much nothing. So the way we deploy our infrastructure as code is by using the open source completely free infrastructure as code service, Pulumi. If you haven't heard of Pulumi before, Pulumi, I could do a couple of hours talking about Pulumi itself. It's really, really amazing tool. We define our infrastructure as code in actual code. So the snippet that you can see here represents the website. And we chose TypeScript mainly because it most closely aligns to the skill set internally. We could have actually also used C#, but C# at that point was still in public preview or not really GA at that point. So we picked TypeScript because our website is written in Angular TypeScript. So whoever writes the website or works on the website can also easily write our infrastructure as code. You can also see in here in this snippet that here and everywhere it's really, we already enforce certain security practices from the get-go. Like here we enforced that the storage account only accepts HTTPS traffic, which, for example, HTTP is already blocked or redirected at the CDN level. And we actually enforce HTTPS end-to-end everywhere. There's no port 80 or anything, communication going on anywhere. So let's get on to the most exciting bit, really, the actual application. I mentioned it's hosted on Azure Functions, which fits our serverless requirement. And it's, or actually not is, it was hosted on a Linux dynamic consumption plan. So yeah, we use .NET on Linux because why not? Because no application ever should care about which OS it runs on, unless you're actually an application that makes changes to the operating system. As long as your third-party packages or dependencies support .NET Core, doesn't matter what you run on. And often it's even cheaper going on Linux. So let's just stick to consumption plan for now, because at the time of writing this slide, I've got an update later on, that was true. The consumption plan is really nice because it automatically scales as required. However, and there's the caveat, each sandbox the functions run in only has about 1 GB of memory available to work in. And yeah, so that's going to become important later on. What's also great about the consumption plan is that the first 1 million executions are free. So for us, that was really good to know because we execute quite a number of functions every month. So in the screenshot to the left, we show the infra code, or you can see the infrastructure as code for the app service plan that hosts the actual function app, and the config for the consumption plan. We already knew that we're eventually going to outgrow the consumption plan, so we already put the code for the premium plan in here. So really, just as the example here, for us to go from consumption to premium plan would literally be remove the comments and redeploy, or actually commit, merge into the main branch and wait for the pipeline to deploy. And 5 minutes later, we would be on a premium plan. So that's what we really like about using these services, the flexibility they give us when demand goes up. The function app itself on the right side has a few more lines of code in it, and the app settings just collapsed them because we don't really need them for the context here. But compared to maybe some of these documents, these implementation documents or run sheets that you might have seen or come across, deploy VM, click here, click there, configure this, type that. This is actually not too bad. You can also see that with this function app as well, we're enforcing HTTPS only. So any HTTP requests are blocked by the infrastructure. Again, nothing we have to do. We also don't have any hard-coded or really even known to us credentials in our app. We use, whenever we do communicate with other Azure services, we use the, like Key Vault, for example, we use the Azure Function Apps Managed Identity. And yeah, it's that one line in here and done. I think, sorry. I think I'm missing a slide in here. Well, anyways, I'm just going to quickly talk about what this slide would have been about. We use for our application, we're heavy users really of queues, storage queues. So if you really what the application does is it scans cloud environments. Yeah, as I mentioned, the CSPM, it scans cloud environments for certain configuration, and we execute many scans. The way it works is our main function runs on a timer trigger. It runs every X seconds, pretty much real time. And what it does is it just goes to the database, figures out what needs to happen, and then for everything that needs to happen, it puts a message onto the storage queue. And then the storage queue, that triggers all these other functions that then get the message of the queue, execute what needs to happen, and then they're done. At the moment, that's around 800 messages every minute. And this number is really only going to go up. So really, every time a message goes onto the storage queue, a function executes. And the really nice thing is these queue-triggered functions, they scale based on the messages that end up on that storage queue, and we only pay for the execution time, which is usually somewhere around 1 to 2 seconds. And all of the scaling is managed by the platform, nothing we have to do, no virtual machine clusters we have to deploy and figure out how to get them up quickly or down quickly. No Kubernetes, sorry, for any Kubernetes fans, no containers anywhere in this talk, by the way. So good that I waited this long. Maybe we're going to see a couple of people drop off now because I'm not talking about containers. Cool. So as I mentioned, scaling, the functions scale automatically. The consumption plan also scales automatically. Nothing we need to worry about. So if we had to get more oomph into our application, then we know we can just deploy into the premium plan. And the way we would redeploy into that premium plan, I've shown that early on. And really the great thing about the queues, as I mentioned, was that they are based on Azure storage, basically on Azure storage. And because of that, they also inherit the Azure storage accounts SLAs, including their durability SLA, which means that whatever you put on, I think they have 11 nines durability SLA on storage account, which means pretty much whatever you put on, you're always going to get it back. Doesn't mean it's always available, always there. That's the very big difference between durability and availability SLA. But once it's back, we're not going to miss that message. We're just going to pick up from where we left off. So that's all great. That was really great. But then this happened. So these are our metrics basically on that function app. And don't worry too much about the actual numbers on the left. I can tell you that the lower third approximately is up to 1 gigabyte, and everything above the lower third is above 1 gigabyte. If you remember what I said about the consumption plan's memory capacity, that only really scales up to 1 gigabyte. So what happened was features were added. We always add more features. We get more people to use the app. We get more users onto the application, onto the platform. And yeah, that's pretty much where we outgrew the consumption plan's 1 gigabyte memory limit. These are all very good problems to have. Yeah, don't get me wrong. I like adding features for our customers. I like getting more people to use the app. I'm very happy about that. So our application was now definitely memory constrained on this consumption plan. So we had a decision to make. We could have probably refactored the app. We could have deployed functions into other function apps, split them up onto other plans, spent time and money really doing that, or just deploy the application into a premium plan. And as that meant that it was really just changing these 2 lines of code and wait 5 minutes for the pipeline to deploy these new infrastructure changes, this was really an easy decision to make. We ended up deploying into that premium plan. So on the back end, for our database, we also had to make a decision. You can probably guess between SQL Server, Microsoft SQL Server, or Cosmos DB. SQL Server, obviously Azure SQL PaaS, not a virtual machine. It's well known in the industry, but it's not cheap. Even when going with that new serverless tier that Azure SQL offers. Even then, Cosmos DB is still cheaper, especially because it also comes with a nice free tier, as long as we wouldn't go and hammer the database too much, which initially we knew we weren't going to do. So that free tier, just like the free executions on the function app for the early days, was really, really good. We were able to go quite a long way without paying pretty much anything, apart from a bit of storage for this application. At the moment, we pay around 300 Australian dollars a month for this Cosmos DB. Sorry, I just keep on saying Australian dollars. We're all in Australia. Force a habit. So we spend around $300 a month on this Cosmos DB now, which is probably somewhere around half of what we would pay for SQL Server, to be honest. And I feel, I'm fairly certain that we haven't even properly optimized our Cosmos DB yet. I know Cosmos DB can get very expensive very quickly if you do strange things on it, and if you don't keep an eye on the scaling metrics on Cosmos DB. But at least that I feel we have under control. And but other than that, we leave pretty much everything up to the platform. Yeah, Cosmos DB comes with some really nice benefits because it's a NoSQL platform. It has super fast writes and reads, which is really important to us because we write and read a lot. It's really simple to integrate into Azure Functions, as in super simple. Couldn't be easier, really. And it still supports SQL APIs when communicating with it, which means that our developers that have a SQL background, a lot of .NET developers have a SQL background or have used SQL databases in the past, they find it super easy to work with Cosmos DB. We don't have to also think about patching and infrastructure, and we get high availability in our region for free, just like storage. there's multiple replicas of data in each region. You can see in our infra code here on the side, if we had to go multi-region, or if we wanted to go multi-region with our database, it would be really easy for us. In this geolocations list, we would just add another region, commit, merge, wait 5 minutes, and it gets deployed. Actually, a zero downtime deployment, which, by the way, all of our deployments are. I've just for our partners, investors, early investors, pulled a couple of metrics out. We deploy a lot, and the application is never down. I think in the last 30 days, we deployed, I think we had around 90, somewhere between 90 and 100 deployments or pipeline runs that deployed the application, and always zero downtime deployment. So using Cosmos DB also meant that it would really nicely scale with our demand. We really only pay for what we use mostly. And when we grow the database, it automatically scales. Or when we grow, the database grows with us. As it automatically scales its request units, just to make sure that our queries don't slow down. Part of the future optimization of the database will probably be to define some scale limits, which we can define using Pulumi. Here's the example, which we currently don't have. So we don't have a throughput defined in our database at the moment. But if we wanted to limit it to 800 request units per second, then this is what it would look like. I encourage you to read up on that request units per second metric and other metrics by Cosmos DB or used by Cosmos DB, because that alone can probably be a couple of days workshop just to understand how Cosmos DB and function apps and all of those use their metrics and costs and pricing models. To give you an idea of our current scale, so for the $300 that I mentioned in the previous slide, we currently execute around 7 million requests to our database every 24 hours. Before I checked those numbers, I wouldn't have gone that high with that number. I would have maybe guessed somewhere around 500,000 requests. But yeah, we read the database and we write to the database 7 million times a day. I haven't checked the ratio between read and write yet. It's going to be way more reads than writes, but either way, 7 million is quite impressive, especially for $300. So let's quickly touch on our third-party integrations, the things we decided not to build ourselves, but buy as a service. Starting with Stripe, which offers that really easy payment integration for our application. They have a really nice startup offer, so we don't have to spend much on Stripe, which is great. It also meant, I mentioned that before, and I really very, very badly do not want to deal, ever want to deal with that. We don't need to be PCI compliant in order to give our customers the ability to put their credit cards into our website and pay via credit card. That probably took us maybe a day or two to integrate. For our code repository and CI/CD, we use GitHub Actions, and we're not paying a single cent, nothing. GitHub has this really great free tier, which gives us 2,000 minutes of pipelines or actions every month. As I said, each deployment probably takes around 5 minutes, maybe 10 minutes for the front end until the CDN has been purged and all of that. But that's plenty. As I said, we had around somewhere between 90 and 100 deployments. Even worst case, 100 minutes, we're barely using half of it. I've answered earlier, I really didn't want to go back to the early days of my career and look after Exchange servers, or maybe a bit more modern, use Outlook APIs, Outlook Office 365 APIs to send emails. SendGrid honestly made it so easy to send emails, even formatted or templated ones, was really a no-brainer, especially because Azure Functions, using their output bindings, supports SendGrid out of the box. So that meant for us, in order to send an email to our customers, all we had to do was add 3 lines of code to our function. That was it. Email capability, 3 lines of code, done. Pretty amazing. And they have a free tier, which made it even better. Auth0, if you're familiar with AAD, or so Azure Active Directory B2C, they offer something similar, but Auth0, looking at the development experience for a modern web application like ours, was just much more aligned with what we wanted to do. We don't ask our users to create logins or passwords. We don't store any of those credentials. I really don't want to know any of your passwords. I don't want to worry about password resets or stuff like that. Nothing. Auth0 allowed us to integrate an authentication service into our website in around 15 lines of JavaScript. And with that, with these 15 lines, we had full single sign-on into our application. We support Azure Active Directory, Google, and many others. We could even support local Active Directory if we wanted to. And all of that kind of took us about an hour. And Auth0 also has an amazing startup offer, which made it even easier to pick them. We did pick those third parties quite carefully, mainly, again, security is top focus for us. But we believe that they do a much better job at these things that you can see here than we could ever do, because that's not our business. If I really liked Exchange, maybe I would have come up with a new SendGrid competitor and figured out how to make email better, but I don't, and I didn't. And so we picked these third parties because they can deliver their value, so we can deliver our value. So that brings us to my conclusions, really, or takeaways after around 8 months or so now of actually building the startup on Microsoft Azure. So focusing on the actual application, on our core application, and only on that core functionality, meant that we didn't need to worry about all these accessory services that I just mentioned in the previous slide. But we were able to quickly build and iterate on our own offering. Integrating all of these and using Microsoft's native services meant that we could, our MVP was up in quotes, no time, and we could take it to very early adopters or very early guinea pigs almost, to just get their feedback quickly, change things quickly, and just keep going. Scaling is built into the infrastructure. In the beginning, as I mentioned, there was almost no load on our infrastructure, but we knew that was going to change. But we didn't know by how much. We had plans and hopes, obviously, but by relying on auto-scaling or being able to make a simple change to our infra code and receive more power on demand, pretty much, we got to the point where we really aren't worried about getting more customers or more load onto this platform. I really don't want to ever show anybody these HTTP error messages that pretty much mean, sorry, I don't understand how to scale infrastructure. Please come back later or never. Really don't ever want to do that. The screenshot here, so over the last 30 days, I just pulled that yesterday, shows that our main application executed around 11 million times. And again, 11 million times of it executing, around 7 million executions against the database. There's some pretty nice numbers here. However, these decisions also meant that we were locked into Azure. I mentioned in the beginning that I think this is good, but it's not great. It's good because we can leverage all the cloud native capabilities, which is amazing. But if we run out of money, for whatever reason, and another cloud provider goes and offers us some really nice credits, which they tend to do, especially when you're in the situation where you need money and you don't want to spend too much on the infrastructure, what are we going to do then? Are we going to spend money on refactoring and trying to move it over to the other cloud? Do I then have to go and containerize everything and move everything over to containers and Kubernetes, manage Kubernetes? I don't know. Personally, my gut feel is locking yourself into a cloud provider as a startup, a product startup, is a really good thing. It did enable us to build this application quickly. It also means that using these more modern cloud services means that people are really eager to work on your application. And using a language like .NET and TypeScript, that's very common, made it even more appealing to people. One thing that we did learn quite quickly, though, was that application insights logging is probably going to be the most expensive part of our application by far. And it's actually still a concern. 11 million executions on the actual app, 7 million writes a day, reads and writes or executions a day on the database. Our application is busy, creates a lot of logs. Logging is expensive. And I actually had 1 month where some change that we didn't fully understand made it into the app, or actually changed to the infrastructure or the app insights configuration. And we didn't catch it, and we didn't look at any of those metrics. And that month, application insights cost us more than the actual application, which is interesting. You can now look at all the logs that you don't need and you didn't want to pay for. So that was an interesting lesson to learn. Overall, however, with these numbers that I mentioned, at the moment, our application costs us around $600 a month, and that's excluding App Insights. Since writing these slides, which I did about a month ago or so, before we moved to the premium plan, we now expect our cost to go up by around somewhere between $300 and $400 a month, because the premium plan is more expensive and we need to scale using auto scaling. The platform doesn't do it anymore for us. We haven't gotten the latest invoice yet, so our estimates are somewhere around maybe somewhere $200 to $400 more a month. So it could still be under $1,000 for this application. But I would say for building a startup that delivers this value, these are pretty good numbers. Knowing that a lot of my past customers probably paid more for a file that had to be hosted on a Windows virtual machine, and somehow ended up on that VM, which was way too big, and just served one file that people had to copy there and back. So I'm pretty happy with those numbers. With that, thank you very much for letting me talk about how we build this product. We're happy to give more information on any of the services that we're using, any of the numbers I've mentioned, any learnings. But yeah, if there's any questions, I think James can check on YouTube. Otherwise, thank you very much. If you do want to get in touch with me, here's my contact details.
Thank you very much for that, David. So I've been watching through the chat. We have one question as it came through, and that was from Vineet around Azure Functions. So Vineet's wanting to know, was Azure Functions an expensive option for you if demand increases over time? So, and you needed to obviously trigger functions to meet that scale.
Yeah, so the answer is pretty much no. We at that scale that we operate on, user requests are pretty much negligible. So we can pretty much grow to having thousands of users on our website, and nothing would really change from our functions usage. And the cost for that, for our functions, as I said, the function app itself is probably going to be somewhere around $500, maybe $600 all up every month, which I think is pretty amazing. I'd much rather be on functions than on any of the other services.
Beautiful. And I suppose I've got one that I find would be interesting is how do you gauge your customer security? Because obviously your platform supports AWS, GCP, and Azure. Do you go off like a baseline, like something like CIS benchmarks, or is it custom rule sets?
Yeah, so it's a bit of everything. Without going too much into a product pitch, I believe that a lot of organizations focus too much on compliance benchmarks, and it's pretty much in the name that these compliance benchmarks have a lot of things in them that are compliance related, but maybe not so much security related. So what we have done is we've looked at many of these frameworks and these benchmarks. CIS is one of them. CIS has some for Azure, AWS, and GCP, although most of them are fairly far behind. And Microsoft has the Azure security benchmark. So we looked at all of them and picked the security-related controls out of them. We added our own based on our best practices and security view. We've worked with our early adopters to create our own custom framework, not framework, but controls. That they told us, look, that's great, but we need to know about this. Yeah. So on AWS, there's no check for dangling domains, for example. Dangling domains are a security issue because somebody can take your domain over, right? And that check doesn't exist in any of the CIS benchmarks, doesn't exist in any of the other frameworks. So customers said that would be super high value to us because we have hundreds of Route 53 entries with domains, with public domains, and we are kind of worried, not because it always happens, but because it could happen, that somebody leaves that dangling domain and somebody else takes over that domain. So we created that control, took us about 30 minutes, and now we're checking all of our customers for dangling domains.
Yeah, beautiful. So it's obviously coming out of an understanding that compliance is not necessarily security, and it's what's providing value to the business. Yep.
Correct. So what I usually say is compliance follows security. Yeah. So a lot of people, and someone gave me that analogy. So we're renters, and you get your real estate agent coming over once every 6 months, your auditor, yeah, at work, at home, and they check your environment. So what do you do the day before the auditor comes? You clean everything up. And the day after they leave, after they're gone, they give you the stamp, say, you're compliant, congratulations. What happens? Things start sliding again. But no attacker cares about, you've probably seen this meme, yeah, hackers don't care about all of these things. One of them is your compliance result, and that's why we check for security issues, which is a subset of these compliance frameworks in real time, and not just every 6 months or 12 months on demand.
Beautiful. All right, well, we've got no more questions. So obviously a big thank you from the broader community for tuning in and presenting. We do appreciate you obviously coming out and spending part of your day.
No worries. Thank you.
Yeah, thank you so much. And I think we'll leave it here. And as always, for everyone who's tuned in, just a quick reminder, we've got our next event on the 16th of March. Until next time, everyone, have a lovely day.